Hello, dear students. Welcome to our maths class. Here I am Sajini John, your maths teacher. Today we are going to learn about similarity of two triangles or similar triangles. Before starting similarity, we have to think about congruency of two triangles. We have already learned about congruency. What is congruency? Or what are the properties of congruent triangles? If two triangles are exactly same, that means if we place one upon another, that means one triangle upon another triangle, they will coincide each other. Then we can say that these two triangles are congruent. And you have to think about the properties of congruent triangles. If two triangles are congruent, their corresponding three pairs of their corresponding sides are equal. At the same time, three pairs of their corresponding angles are equal. Do you remember the postulates of congruency? There are 5 postulates of congruency. They are SAS, SSS, ASA, RHS, and one more AAS. 5 postulates. Okay. Now we can go to similarity. Similarity of figures. Here you can see some squares. You can see 4 squares are there. 4 squares you can see. 3 circles you can see. Okay. These figures, look here, these figures are similar. That means their shapes same, right? And all circles are similar because shape of that figure, closed figure, same, right? And that means two figures are said to be similar if they have the same shape but may differ in size. Here you can see sizes are different. Okay. But in congruency, two figures are congruent if they have the same shape and the same size. Now we can go to the next, similar triangles. What do you mean by similar triangles? Look here. You can see two triangles here. Same shape. So we can say that these two triangles are similar. That means two triangles are said to be similar if their corresponding angles are equal. Corresponding angles are equal and the corresponding sides are proportional. I will tell you how it comes. You just look here. Corresponding angles are equal. If two triangles are similar, corresponding angles, suppose triangle ABC and triangle PQR. Look, angle A equal to angle P, angle B equal to angle Q, and angle C equal to angle R. Suppose the sides, we can assume the sides of this bigger triangle 6, one side AB 6, AC 10 and BC 4. And in the smaller triangle PQ 3, QR 2 and PR 5. We know that the corresponding sides are not equal. We can check whether they are proportional or not. You just see AB by PQ. What is the result? AB by PQ is 2. 6 by 3, 2. AC by PR, 10 by 5, again 2. BC by QR, that is also again 2. Therefore, we can say that corresponding sides are in proportion. And one thing you have to remember, How can we find corresponding sides and corresponding angles? How? That is very important. Identify corresponding sides or corresponding angles. You can see two similar triangles here. In this similar triangles, the sides opposite to equal angles. Here we know that angle B equal to angle Q. Opposite of angle B is AB. Opposite of angle Q is PR. So these are the corresponding sides. That is very important. Okay. And angle A equal to angle P. Therefore, opposite of angle A is BC. Opposite of angle P is QR. So these are the corresponding sides. In this way we can find corresponding sides. And corresponding angles. If we want to find corresponding angles in similar triangles, the angles opposite to proportional sides are corresponding angles. These two are the proportional sides. So opposite angles are corresponding angles. Okay. And congruency, here also we can see some postulates. Here there are only 3 postulates. I will explain 3 postulates just to see. First one is AA postulate. AA postulate. That is, if one angle of a triangle is equal to any angle of other triangle. Look here, first one is AA postulate. Once again I will repeat, AA postulate. If these two triangles have at least 2 pairs of corresponding angles are equal, then the triangles are similar. If at least 2 angles, here these two, that means angle C equal to angle R, angle A equal to angle P. Automatically angle B equal to angle Q. So this postulate is known as AA postulate or AAA postulate. 3 A's. Okay, that is the first postulate. Second one is SAS. Here, that is, if one angle of a triangle is equal to any angle of the other triangle, and in both the triangles the sides including the equal angles are proportional. Here you can see in this particular figure, AB by PQ is equal to 10 by 5, 2. And AC by PR is 6 by 3, that is also 2. That is, corresponding sides are proportional. And this angle mentioned is, you can see, that is including angle. Okay, included of these two sides, including angle. Therefore, if one angle of a triangle is equal to any angle of the other triangle, and in both the triangles, the sides including the equal angles are in proportion, then the triangles are similar. Okay, the last one is SSS. That means if two triangles have their 3 pairs of corresponding sides proportional, then the triangles are similar. That is SSS postulate. We are usually using AA postulate for the given problems. Usually we are using this postulate. In some cases we can use SAS. Okay, so you have to remember the postulates of similar triangles. Now we can do one question. That is exercise 15A, first question. In the figure given below, straight lines AB and CD intersect at P and AC parallel to BD. Prove that triangle APC, you can see the figure. Triangle APC and triangle BPD are similar. First we have to prove that. Then second case, if BD equal to 2.4, here written there 2.4, AC 3.6, AC 3.6, PD 4, PD 4 centimeter and PB 3.2 centimeter. Find the length of PA and PC. PA and PC. First we can prove these two triangles are similar. You can see the two triangles. You have to prove these two triangles similar. We can see how can we prove it. So we can consider these two triangles. As usual. Okay, in these two triangles, we can see these two angles. These two angles are vertically opposite angles. Therefore, these two angles are equal. Therefore, angle APC equal to angle BPD. Vertically opposite angles we can write. Okay, here statement, here reason. As usual. Now, see. It is given AC parallel to DB. That is given in that question. AC parallel to DB. Okay. If these two lines are parallel, it is the transversal. Look, AB, either AB or CD. These two are the two transversals. Therefore, we can write, what about these two angles? Interior alternate angles. In two parallel lines, it is cut by a transversal. Interior alternate angles are equal. Therefore, these two angles equal. Similarly, these two also interior alternate angles, they are also equal. Either you can write this or this. Okay, any one, that is enough. Two statements. So, angle CAP equal to angle DBP, interior alternate angles. So, by AA postulate, corresponding two angles are equal. Therefore, these two triangles are similar. This is the symbol for similarity. This one. Do you remember symbol for congruency? This one. Equal to sign and one is like this. Congruency. Here, this is similarity. So, these two triangles are similar. It's proved. Now, we are going to find out PA and PC. Where is it? PA and PC. If these two triangles are similar, we know the property corresponding angles are equal and corresponding sides are in proportion. That is the definition of similarity, no? Therefore, if the corresponding sides are proportional, we can write the sides, corresponding sides in proportion. Once again, you have to remember how to identify corresponding sides. The sides opposite to equal angles are corresponding sides. In this way, we can find corresponding sides and they are proportional. AC by BD equal to AP by BP equal to CP by DP. Here, the sides of numerator having the sides of the same triangle. Denominator having the same sides of same triangle. Like this, you have to write. Now, consider the first two. That is AC by BD. AC is given, BD is given. We are going to find AP. And BP also given 3.2. Substitute values and we can see AP is equal to cross multiply and get your answer. That is, when you simplify, you will get the answer 4.8. Now you can see we are going to find CP. CP is here. So these two we can choose. AC by BD is equal to CP by DP. Substitute values, the given values. Here CP is not given. Now cross multiply and get CP is equal to 6 centimeter. Okay, when you simplify, you will get CP is equal to 6 centimeter. So once again you have to remember the postulates of similarity and the properties of similar triangles. The next class we can see more questions. Thank you.